In this video, I will show how you can get started with R. R is a free software tool which is commonly used for data analysis. We will first see how to install R and RStudio, and then see how to get started with some coding. We will also see how to import an Excel file, and how to install and load a package. At the end of this video, I will show how to use appropriate data types, which is crucial to understand before you start analyzing your data. So, if you go to Google and search for CRAN R, you will find this link that will take you to the site where you can download R. Depending on which operating system you use, you can select one of these links. Since I use Windows, I click on this link. Then we select this link to install R. In this case, I will install the version 4.4.2, but they update R all the time, which means that you will probably install a newer version when you see this video. If you click on this link, it should start to download the installation file. After you have downloaded this file, you can run it to install R. Once you have installed R, you will probably have an icon on your desktop. To start R, we simply click on this icon. Then we can open a new script and start to use R. However, most people who use R install RStudio on top of R. This is because RStudio looks nicer, provides more functionality, and is much easier to work with. To install RStudio, we can simply search for RStudio and click on the link RStudio Desktop or the link below. Then we can navigate to the page where we can download the free version of RStudio. This part tells us that we first need to install R to use RStudio. If you click here, it will take us to the same page we previously used to download R. Since we have already installed R, we close this window and click here to download the installation file for RStudio. After you have downloaded the installation file, run the file to install RStudio. When you open RStudio for the first time, it will look something like this. The first thing that you can do is to change the theme by selecting Tools and then Global Options. And then Appearance. Then you can select the type of theme you prefer. I will here select this theme because I think it looks nice. Once you have selected a theme that you like to use, click Apply and then OK. The first thing that we should do in RStudio is to open a new script, like this. So the top left panel shows our R script, where we should write and edit our R code. This panel is called the console, which will display the output when we run the script. This panel is mainly used to view the environment, which will show objects and variables that are stored in the current R session. This panel is mainly used to view plots and access the R documentation and packages. If you click on the tab Files, you will see which files you have in your current R working directory. Okay, let's see how to use R with some simple examples. For example, if we type 7 plus 7 in the console and hit enter, we see that we can use the console as a calculator. If we instead type 7 plus 7 in the script and hit enter, nothing will happen. This is because we first need to run the code in the script. To run this code, we select it and click Run. Note that the output from our calculation is shown in the console. Let's create our first object, also called a variable, that we call x. Objects are used to store data in R. To assign the variable x with the value 2, we can write like this. Then we select this line and click Run. After you have run this line, note that this panel shows that we have created a variable x, which stores the value 2. The console also shows that we have run this line. To print the value of x in the console, we can select only x on this line and press Run. Note that the value of x is printed in the console. We can also print the value of x by using the function print. If you run this line, the value of x will be printed in the console. Let's create a new variable that we call y and assign it the value 5. If we now type x plus y and run this line, we'll get an error, which says that the object y is not found. This is because y is not stored in the memory yet. We therefore need to first run this line to create and store the object in R. Note that the object y is now stored and that it holds the value 5. We can now run x plus y. We can also easily change the value of x, but note that we then need to run the line again to update its value. We can now run x plus y and see in the console that the sum of these two objects is now 8. Note that we can select several lines like this and run them at the same time. To assign values to objects, we have previously used the equal sign. However, it is also common to also assign a value to an object by instead using the symbols less than and a dash. This works in the same way as the equal sign. I tend to use the equal sign because I'm used to it. Then we run the code to compute x plus y. Similarly, we can change the value of x and run the code again. Let's delete this code and see how to create a dataset in R. We will here enter the weight and height of 5 individuals. We first create an object that we call weight. To assign several values to an object, we use the function C, which stands for concatenate or combine. Then we add the weights in kilos of the 5 individuals, where we separate the values with a comma. This type of object is called a vector, which stores a sequence of numbers or characters. Next, we create a new vector with heights in centimeters of the 5 individuals. Then we run these two lines to store the two vectors in R. Note that the vectors are also displayed in this panel. We can print the content of this vector like this, and note that the values are displayed in the console. Similarly, we can print the content of the second vector. Usually we like to create a table of our data. This can be done with the function data.frame, which combines the two vectors. Note that when I start typing the name of the vector height, R displays a suggestion for the input. To save time, I can click on this box and the correct name of the variable is then added automatically. This is handy to use because we will then avoid possible spelling mistakes. If we run this code, we can see that we now have a data frame with the name df stored in R. The data frame has 5 observations and 2 variables. Let's print the data frame. We see that we now get a nice overview of our data in the console, where the column names of the data frame correspond to the name of our two vectors. Note that if we happen to make a spelling mistake or do not use the same capital letters as used for the vector weight and run this line again, then we will get an error because the object weight with lowercase letters is not stored in R. One of the most common errors you will make in R is due to spelling mistakes or incorrect use of lower and uppercase letters. Let's calculate the average weight of the 5 individuals by using the function mean. We see that the average weight is 76.4 kilos. Another way to do this, which is the recommended and most common way, is to instead use our data frame. We first type the name of the data frame called df and a $sign. Note that RStudio now displays the column names of the data frame. We can therefore click on weight. This is a great way to work with RStudio because you will then avoid possible spelling mistakes. To run a line in R, we can either select the line as we have done previously, or simply just put the cursor at the beginning of the line and press Run. We can also compute the average height like this. One of the most common mistakes beginners make when they run a line is that they do not select the full line of code. Usually, they forget to select the last bracket like this. This will result in that the code has not been executed and that a plus sign is shown in the console. This means that R waits for you to end the line. You can either run the thing that you have forgot to run, or simply click in the console and click Escape to get rid of the plus signs, and then try to run the line again. Let's create a scatter plot of the weight and height of the 5 individuals with the function plot. We then enter the name of the data frame and select the columns we like to plot. Note that I get an error when I run this line. This is because the plotting window is too small to create a plot. If this happens, you simply increase the size of the plotting window and run the code again. Note that the labels of the axes correspond to the names we used in the plot function. If we instead use the names of our vectors in the plot function, the labels of the axes will now correspond to these names. Anyway, in most cases we use the name of the data frame and the name of the columns in the data frame. So, to change the labels in the plot, we use the arguments xlab and ylab. If we now run the line again, we will get nicer labels on the axis. Suppose that we would like to rotate the y-axis labels. This can be done with the argument las, where we set it to 1, which will generate horizontal y-axis labels. So, how do I know what kind of arguments to use in a function? Well, to get such information, we can use the help function and the name of the function we like to use. Here you can see the default arguments that are used in the function. Note that not all arguments are shown. For example, xlab is set to null, which means that it uses the name of the vector used in the plot function as default. With the argument main, we can set a title above the plot. If we do not use this argument, no title will be shown. Here you can see information about the arguments. Let's try this argument, which will set the limits of the x-axis. If the line becomes too long like this, we can break the line to show it on 2 rows, so that we can see the full line. But note that we now need to select both lines to run the code. Okay, let's add the argument xlim and say that we like to go from 60 to 100. If we now run the code, we see that the x-axis now spans from 60 to 100. Let's try to generate a histogram of the variable weight by using the function hist. We can either use the name of the vector or the name of the data frame followed by a $sign and the name of the column in the data frame. Note that you can navigate between the plots like this. We see that we have 2 individuals with a weight in the range between 65 and 70. No individuals with a weight in the range of 80 to 85. And 1 person who has a weight in the range of 85 to 90. We can change the label of the x-axis like this. Let's have a look at the documentation of the function hist with the function help, or by using a question mark followed by the name of the function. Note that, per default, the color of the bars is set to light gray. Let's change the color to blue by using the argument col. If you now run the line, the bars of the histogram will turn blue. We will now have a look at how we can import data from an Excel file. we will create an Excel file with the same dataset as our previous data frame. Let's open Excel and enter our data. Then we save the file with the default name book1 and close the file. I have here saved the file on my desktop. To import a data file, we go to Import Dataset. If you like to import a data file other than an Excel file, such as a CSV file, you can choose one of these options. To import an Excel file, we select From Excel and click Browse to find the file. This window shows a preview of how the data will be imported. Double means that the variables are interpreted as numeric data in R. Note that this option should be selected because our Excel file includes column names on the first row. Then we click Import. Note that the following code has been generated in the console. It shows that R has loaded the package readXL, which is required to read an Excel file, and that our dataset has been stored in the object book1, which is the same name as our Excel file. Then it runs the function view, which opens a new tab up here that displays our data. Let's print the object book1. This looks very similar to our previous data frame, but this object is actually called a tibble. What's nice with the tibble is that it shows the data type of each column in the output. DBL stands for double, which indicates that the two columns are interpreted as numeric columns. Just as we did before, we can now compute the average weight of the 5 individuals by using the function mean. By using the name of the tibble followed by a $, and then select the column weight. If you like, we can use another name of the tibble by simply copying the object book1 into a new object that we, for example, name data. We'll now have two objects of the dataset, data and book1. For example, we can now calculate the average height of the 5 individuals by using the tibble data. And create a histogram of the heights like this. To view the data stored as a data frame or a tibble, we can print its content in the console like this. However, if you have a large dataset, it will be very hard to read in the console. A better way to view such data is to use the function view. Which opens the following tab. In this tab, we can, for example, search for things and also filter. Once you are done reading the data, you can just close the tab. We will now see how we can install and load a package in R. Packages include functions that are not included in the basic R installation. To use a function in a package, we first need to load such a package with the function library. We will here load the package beep-r. The reason why we now get an error is because we have not installed this package. To install a package in R, we use the function install.packages and the name of the package we like to install. Note that we here use quotation marks. When we run this line, the installation starts. Note that you need an internet connection to install a package. We see that 2 packages have actually been installed. In addition to beep-r, it has also installed the package audio. The reason why it has also installed the package audio is because the package beep-r depends on the package audio. This means that the package beep-r uses functions in the package audio, which is the reason why this package also needs to be installed. Once we have installed a package in R, we never need to install it again unless we install a newer version of R. Make sure that you remove this line from your script so that you do not happen to install the package again. Once we have installed a package, we can now load it with the function library. If you get an error when you load the package, it means that the package was not successfully installed. Then try to copy the error message or the error message generated during the installation and search for it on Google, or paste the error message in an AI tool such as ChatGPT to get help. If you get a warning that says that the library was built on another R version than you use, don't worry, because a package usually works fine to use even though you get such warnings. Okay, we are now ready to use a function in this package. Let's try the function beep. When you run this function, you will hear a beep. By using different numbers in this function, we can generate different beeps. Note that every time you open a new session in R, you need to load the package in order to use its functions. If you check the tab Packages, you will see which packages you have installed. I have previously installed hundreds of packages, so my list is quite long. To unload the package beep-r, you can uncheck this box. If you unload this package, which also happens if you close RStudio, you can no longer use the function beep. To use the function beep, we need to load the package beep-r again with the function library, or simply check this box. Finally, we will have a look at different data types in R, which is crucial to understand. I've here prepared a piece of code that illustrates this. If we run the first line of this script, we create the object x and assign it a value. If we now run the function class, we see that the data type is numeric, which means that the object stores a number. If we run the function typeOf, it prints the internal storage data type of the object. Double means that the object can store decimal numbers. This is the default type for numeric values. If we now run this line, and then the function class, we see that the object stores characters, which basically means that it stores letters or symbols. If we now run this line, which creates a vector with numbers, we see that the vector holds numbers. and that we can compute the mean of these numbers. Missing data is defined by NA in R. Suppose that the weight of the third person is missing. We then set the third element in the vector to NA. The data type of the vector is still numeric. But if we now try to compute the mean of this vector, we will get an output that says NA. Let's have a look at the documentation of the function mean. Per default, the function does not remove missing data because the argument na.rm is set to false. If we scroll down a bit, we see that we can set this argument to true in order to remove missing values. Let's add the argument na.rm inside the function and set it to true. The function now removes the missing data before it computes the mean of the two values. Suppose that we would add a character string in the vector. If we now run the function class, we see that the class of the vector is now defined as character. If we print the content of the vector, we see that there are quotation marks around the numbers, which means that these numbers are now interpreted as characters. This is because a vector can only have either numbers or characters, not both. If we would try to compute the mean of this vector, we will get the warning that the vector does not contain numbers. Let's change the last element in the vector back to 55. We will now run this line, which holds the names of the three individuals. We also need to rerun this line, because the vector still stores hello in the last element. After running this line, the vector now stores the value 55 in the last element. We now run this line to create a data frame of our data. The reason why I here get an error is because I do not have a vector with the name height. We should therefore, of course, put the name weight here. We now run this line again and print the content of the data frame to make sure it looks okay. Next, we run the function class, which tells us that the object df is a data frame. To view the data type of the columns in our data frame, we can use the function str. The function shows that the column names has the data type character, whereas the column weight is numeric. If we like, we can convert our data frame to a table by using the function as_table, which can be found in the package table. We therefore first need to load the package table. Remember that you might need to install this package first. Note that I here use these symbols, which is the same as using the equal sign. If we print our table, we see that the data type of each column are displayed in the output. Okay, let's now delete this code and import the following Excel file with the name my_data, which looks like this. Note that we here have a missing value for the blood pressure of person number 5. We'll now import this file. To clear up a bit, we can click here to remove our old objects from the environment. We now import the Excel file, just as we did before. Note that the preview shows that it interprets the missing data as NA, just as it should. However, if you have used some special character to define missing data in the Excel file, you should enter that one here, so that R understands how to interpret missing values in your Excel file. Note that the preview shows how R will interpret the data types of each column. The column disease here holds zeros and ones, where the zeros represent no disease and the ones define the disease. R doesn't understand this and interpret this column as a numeric column. This means that we later need to define this column as a factor. Note that the imported data has the name my_data and is stored as a table. Let's print the content of the table to see if it looks okay. Note that the name of the column blood pressure includes backticks. The reason for this is that the column in our Excel file includes a space in the name, which is true also for this column. Let's compute the mean weight of the 5 individuals by using the name of our table, followed by a $sign and the name of the column. However, note that we can no longer use the name weight, because we have no object called weight. This explains why we will get an error if we try to run this line. So, to compute the average weight, we need to use the name of the table followed by a $sign and the name of the column. One crucial step we need to do before we start analyzing data in R is to define our variables. These two columns include categorical data, which should therefore first be defined as factors. This can be done if we convert the existing columns to factors by using the function factor. If we now print our table, we see that the two categorical variables are defined as factors. The first column should have the data type character, because it includes the names of the individuals. We can now compute, for example, a t-test to see if there is a significant difference in the blood pressure. Between the two age groups. Note that most functions in R allow that you just type the column names of the data frame or table like this. But we then need to set the argument data equal to the name of our data frame or table. If you like, you can convert a table to a data frame like this. If we then print the data frame, note that the column names have been changed. The backticks have disappeared, and the space in the name has been replaced with a dot. Let's print our table my_data again. It is inconvenient to have complicated column names in our table with backticks like this. One way is to rename the columns with the function names. We then need to type in new names for all the columns. If we now print the table, we see that we now have much simpler names of the columns, which are easier to work with. However, if you have many columns and only want to rename some of the columns, we can use the function rename, where we first add the name of the table and then the name of the column, and finally the name of the column that we like to rename. Remember that you might need to install this package if you have already not done that. This was the end of this basic video about R. Good luck with the coding.